is the lecture number 18. Today we are discussing about the AVL tree. My suggestion to everyone, at first you must complete the lecture number 13. In lecture number 13 we have discussed about the tree, subtree, strict binary tree, full binary tree, forest, complete binary tree, and also we have discussed about the level, height, children, node, leaf, depth and edges. Okay, we have discussed a lot of about the topic, and after then you must go in the binary search tree. Okay, what is the binary search tree? You must go lecture number this is 16, lecture number 16. You must go lecture number 16. So then you must come in lecture number 17. So this is also very important. Then you must come in lecture number 18. Then you will understand actually what is the AVL tree. Okay, so it is totally depend on the 3 lecture. Okay, so today what is AVL? So this is the 3 scientists, they have discovered this such type of balanced search tree. Okay, this is balanced search tree. Okay, so this is AVL. These are the name of the scientists, Adelson and Velsky and Landis. Okay, these are 3 scientists. They have discovered this balanced search tree. This is a balanced search tree where the difference between height of the left subtree and right subtree cannot be more than 1. This is the definition of AVL tree. Means your height. Suppose you have this tree. Okay, this is tree. Okay, the height of the left subtree, it will be all time less than the right subtree. Okay, its mod, it will be less than 1. Okay, every time its mod is less than 1. Okay, how to count the value? This is the question. So we have written something. If height of left subtree is less than height of right subtree, in this condition the value you will write -1. Okay, for the node. If height of left subtree is equal to height of right subtree, then you will say that this is 0. You will write in this condition 0 for the node. If left subtree is greater than height of the right subtree, in this condition you will write +1 for the such node. We will just explain you by the help of this example. Okay, if they have not given us any node, okay, in this condition you will take this is -1, the first condition. Now if there is for the leaf node, its value is equal to 0. Okay, so you know that 0 it is greater than this -1. 0 is greater than -1. Okay, it means that HL is greater than HR. In this condition this is +1. Okay, this is +1. Okay, now there is no value, this is a leaf, then its value is 0. Okay, so now this is 1 and this is 0. This is 1 and this is 0. Again, HL is greater than HR. Height of left subtree is greater than height of right subtree. In this condition, its value, it will be +1 because of this property. Okay, now this is a leaf and its height is 0. Again, this is greater than this. Again, we will take this is +1 because of this condition. Okay, there is no value, so we will take -1. Okay, there is no leaf. Okay, so we will take -1. Now you can see also +1 is greater than -1. In this condition also it is +1. So you can see that this tree, it is following the HL minus HR is less than equal to 1. In every case, the value, it is not increasing than 1. In this condition, this is the AVL tree. Okay, this is another example. Here I am taking this another example. Here they have not given us. So this is -1. This is the leaf node and its value is 0. The height is 0. So the height, left subtree height is 0 and right subtree height is -1 because there is no leaf. Okay, so 0 is greater than -1. In this condition your value is +1. Okay, there is a leaf node, so its value is 0. Okay, so 1 is greater than 0. 1 is greater than 0. In this condition again its value is +1. Now there is no value, it means that there is -1. This is the leaf node, its value is 0. 0 is greater than -1. It means that this is +1. Now if both are same, then this value is 0. Now you can see that everywhere the node value is less than equal to 1. In this condition, this is the AVL tree. Okay, they will give you in the exam they will, suppose you are preparing for GATE exam, okay, so they will give you 4 options and they will ask that which one is the AVL tree, okay. So in this condition you have to use this property. If it is satisfying all the property, then it means that in this condition you will say that this is the AVL tree. How to insert an element in the AVL tree and delete an element in AVL tree? That is very simple. Go in the binary search tree, how to insert, okay. In lecture number 17 we have already tell you, and whenever you are inserting the data, at that time you have to use this algorithm, okay. You have to check the left subtree must be less than right subtree, okay, or then you will write -1. If left height of the left subtree is equal to right subtree, then you will write 0 for this node. Means the condition of the AVL tree must be followed whenever you are inserting an element, okay. You will insert like in this manner, okay. That is the insertion and deletion of the AVL tree, okay. So that is sufficient to teach you, okay. Thank you so much.